this video session. In this session, we'll discuss about how to create a deep learning method combination case studies using different datasets. Here, we use dataset name Cifar 10 to create deep learning method augmentation case studies. Here, first of all, step 1, we import the libraries using NumPy, Pandas, Microdata Creating, Seaborn, TensorFlow. When we go to layers, then drop out sequentials, conversion to the next tool, to the etc. And then the step 2, that is loading the data. Here, we use the dataset named as Cifar, right? We use these functions to load the dataset. Then we check the type of the training data. Then we retrieve the first elements or pairs from the datasets. In these datasets, these are the class names, includes airplane, automobile, boat, cat, key, job, frog, horse, sheep, truck, etc. And then next step, we view the data. This is the function to do this data. Here we bring the variable name versus we bring the value using this function. Here we check the shape of the image. We bring the label name and we give the title label name. So the shapes of these pictures. And next, using this function, we extract 5 samples from trained data for visualization. This is the 5 samples of trained data. We bring it. Next, we draw the extract images using this function. Here, this code need to create a visualization of 3 images with their respective labels using matplotlib. Then with step 3, that is basic pre-processing. Here, we bring the image shape of the data because here the Cifar images are already 32. Then we use the resize and rescale. Here we ensure consistent size because we have size already 32. And then we normalize the pixel value size to 0, 1 using this rescale function. And then we print the result of the image. These are the images. In the step 4, that is method augmentation. Using these data augmentation functions, we flip these images to horizontally and vertical, and then we have random rotation and random zoom. Here, the image of 0, it refers to accessing the first element of a list or array named images. Here, using these functions, we combine pre-processing with augmentations. Here, we put the images and order, and we return the images on label. Here we use the resizing scale, this is. After all these functions, this is a image we printed. It's an image of resize and rescale. Next, we optimize data loading and apply pre-processing for the training, validation, and testing purposes. Here, the batch size is 32. Here, we apply pre-processing to datasets. This is the train dataset. This is the validation dataset. This is a test datasets. Next, we build the model using these functions Here we define the model, sequential. This is the size. Here we apply 32 filters of size 3 into 3 to extract the features. And then here we use the value function, means the accuracy function, rectified linear views. That is value. And next, we apply 64 filters of size 3 into 3 for deeper feature extraction. And next, here we apply 128 filters of size 3 into 3 for deeper feature extraction. And then we go the accuracy function value. We use the flat. Next, the dense 128 here. These are the neurons, 128 neurons. Then we activate the range function. And last, we drop out these functions. Here, Cifar has 10 classes. For these functions, these are the we get data. Next, we apply pre-processing of the image. Here, we apply resize, grayscale, and data augmentation to our training data before feeding into the model. And next, here, we apply pre-processing to the data sets, train data, validation data, and test data. Here, using this function, we convert into batch cells. Here, we can adjust this value based on your resources, system resources. Next, we compare the model using this of the optimizer Adam adaptive movement estimation. After combining the model, we train the model using these functions. We train the across 3. And next, we evaluate the model using these functions. Here, we use the data augmentation to build and train the model. Next, without data augmentation, to build and train the model. Here, without the data augmentation is the same step needed. First of all, we load the data set. And then get the class names. These are the class names. And the Cifar 10 image 32, the image size 32. We apply similar data sets, convert into batch, and we create again this row again. Next, we visualize a few images from the training data sets. This is the images, the training data sets. And next, we build the model using these functions, the same function. And we compare the model using the Adam kernel, and then we train the model. And at last, we evaluate the model using these functions. Here, we visualize the training results using these rows separately. First one, accuracy, and second one, the lowers. Next, we create another deep learning data augmentation case studies using another data set named as Cifar 100. Here, first of all, we import libraries, NumPy, using NumPy pandas, network Seaborn, TensorFlow, we import layers, models, then sequential, conversion theory, max theory, fractal, etc. And then step 2, that is loading the dataset. Here, we load the dataset named as Cifar 100. Then Here we split the dataset into training and testing datasets. And next, we check the type of the training datasets. And then we retrieve the first element or pairs from the dataset using these functions. This is our answer we get. And then we view the data using these functions. This is the data we get. These are the data. Here we check the shape and print the label names of this data using these functions. Here, using these functions, we extract 5 samples from training data from 4 visualizations. This is the 5 samples of the dataset. Then we plot the extract images. Here, using this code, snippet creates a visualization of 2 images along with their respective labels using matplotlib. Then the next step, that is step 3, basic pre-processing. Here, this is the image size 32. Then we use the resizing scale. Here we resize. Here we ensure persistent size of Cifar handles are already 32. Then we rescale. Here we normalize the pixel value to 0, 1. These are the results we get. This is in this case. The step 4, that is data augmentations. Here we flip this image horizontal and vertical, and then we random rotate this image, then random assume this using these functions. Here, this image 0 refers to accessing the first element of a list or array named images. Here, using these functions, we combine preprocessing and augmentations. After all these functions, we get the image. This is grayscale, resize, and less scales. The next step, we build the model using these functions. 32, 33. Here is 32, 64, 64. Here we apply 64 filters of size 3 in the tree for deeper filter extractions. Here, Cifar 100 has 100 classes. And then we apply preprocessing to datasets. Here, we use the trained datasets and test datasets. And then we compare the model using these ADAM optimizers. It is adaptive movement estimation. And then we train the model using these functions. We train variables 5. And then we evaluate the model using these functions. For these functions, we build the model using the without data augmentations. Here, the same step we did later. We load the data sets, Cifar 100, and then we check the class names. These are the class names. This is Cifar 100. Next, this is a Cifar 100 image size 32 because Cifar 100 and Cifar 10 is 32 by default. Here we normalize the pixel values to 0, 1. And then we apply pre-processing to datasets, training and testing datasets. Here we validation split into 0.2. Here we split the brain dataset and Venus dataset. Here we take the first 80% of brain dataset and skip the first 80% to create validation datasets. These are the byte size of Cifar 132. Here we split the data into train dataset, validation dataset, and prediction dataset. Here we using this function to visualize a few images from the training datasets. This is the images of the training datasets. And next, we build the model using these functions. So the same function we did it. Then we compare the model and train the model and evaluate the model using these functions. Compare, train and evaluate.